Hello, and welcome everyone to Global XR Talks, our monthly event where we invite speakers to give talks on everything related to virtual reality, augmented, and mixed reality. Hi, Sjoukje.
Hi, Saskia. How are you?
I'm great. How are you?
I'm great as well. I first want to congratulate you with becoming an MVP.
Oh, thank you. Thank you so much,
Yeah,
actually. Look what
well
arrived today.
deserved.
My
Oh,
award.
yeah, there it is.
Thank you. But let's not talk about us, because I am super excited to have two really awesome topics today and two really awesome speakers. We have two topics that we have never had before. Um, Non-fungible tokens or NFTs, a really hot topic at the moment. And our first talk is going to be about light fields, something we've also never talked about before. And I suggest with that we welcome our first speaker,
Yes.
Milan Pollé.
Hello,
Hi, Milan.
Hi.
really fun to be here. Thanks for the opportunity to talk about my current obsession, which is light fields, because I just
Well,
received a light field display recently. So,
we
Sounds
are
great.
super happy to have you. It sounds really great. I mean, light fields are it's one of my favorite topics personally. Um, I don't want to talk about it now because Milan is going to tell us all about it. He's also going to introduce himself.
yeah,
So, without further ado, let's just start.
Yes.
Milan, want to
okay,
share your screen?
Good
yes,
luck.
my screen is shared already. Let me just quickly switch to my. Yes. So, thanks all for joining my presentation. So, like I just said, today I'd like to talk to you about something called light fields. But first, as also just said, I'd like to introduce myself. My name is Milan Pollé. I'm currently an XR expert at Ordina. I've been working there for over 5 years now, only on VR, AR, and mixed reality projects. We use that for training and for work desk support, things like that, education. I have a background in broadcast television and video games as well, for which I've done programming, 3D graphics and animation, sound design, as well as video content creation. And I also sometimes make the music for those videos. So what am I going to be talking about today? First, I'll start with the history of capturing light. Then I'll kind of talk about what a light field is, then the benefits of light fields, the current practical limitations of them, ways to capture light fields, experiencing light fields, and what the future developments are. So unless you're in complete dark environment, you're constantly being bombarded by rays of light coming in from every direction. Sometimes they even get into your eyes, which can really hurt if you're staring directly at the sunlight. So people have been trying to capture light for more than 2000 years already, which started with something called the camera obscura. And that literally means a dark chamber. So it is a dark chamber with a tiny hole in the wall to which the outside world is projected upside down on the opposite wall. And the hole in the wall is really tiny, and that causes the projection on the wall to be completely sharp. So front to back, everything is in focus. Now, why is that? That's because the hole is so small that the whole image is made out of light rays that are directly coming from the direction of the small hole in the wall. They're not mixed in with other directions that are slightly deviating from that one. So on the left, you see a table, and there's also light from the outside being projected on it. There's no electronics. The image is coming in from a small hole in the ceiling, and on the roof is a small mirror, so you can see the outside world projected onto the table there. Also, the whole screen is, or the whole image is completely sharp. So the earliest cameras, they use a pinhole instead of a lens. So that's also the same principle. It's also a very tiny hole. So this also produces a really sharp image. The only drawback of this is that there's very little light coming inside of the camera. So if you want to take a picture, you have to have a really long exposure time. So I don't know what's going on with the guy on the left in the image here. It doesn't look really comfortable, but that might be a way to keep him perfectly still during the long exposure time of the camera. So how can we decrease the shutter time? One way would be to increase the diameter of the small hole so more light gets inside the camera. This we call an aperture. So what is the side effect of an aperture? As the aperture is opened more and more, your depth of field gets less, which means that the distance range where your image is sharp is decreased. So that's a drawback of getting a better shutter time, is usually that you lose sharpness in your image. More of your image is out of focus. Now to select which part of your image, which distance is in focus, you could move the focal plane or you could move the lens. And moving the lens is what's usually done in practice to focus. You adjust the lens and your lens is moved slightly to focus the image directly on your sensor with digital cameras. And then there's another aspect of traditional lenses, which is partly the distance between the sensor and the lens, so the focal plane, and also this is combined with the shape of your lens. And this defines how strong your perspective effect is, and also how much of your environment is captured. So how wide your field of view is. So you can see that on the left. You can see the image animating between 28 degrees of vision and 74%. So there you can see that the focal length changes your field of view. And this is also called a zoom factor, and it ranges between a wide lens and a telelens. Very wide lenses are fisheye lenses, where the image gets really distorted. But all of these settings, the photographer does before actually capturing the image. In this way, all the original directions that the light was coming in from are lost. And digital cameras, as you can see at the top right, they even prefer all the rays to come in straight on. So on the bottom left, you see an array of micro lenses, which help to aim the light rays directly at the sensor of the digital camera, so it gets maximum exposure. But if you want to change any of the camera settings after already taking a picture, that is impossible. You cannot do that anymore because the information is lost. So what if we could capture the directions of the light rays as well for every pixel of the image? And this we call a four-dimensional light field. It's like a regular 2D image, but the horizontal and vertical directions are added to each pixel. So that makes it a four-dimensional image in total. So the directions of multiple rays are stored per pixel. What could we do with this if we stored the directions of the light rays as well? Well, we could create a virtual camera lens model. So we could do this in code. And then we could do all the lens adjustments after taking the image. So you could do that anytime you like. When you're reviewing the photos you took, you can still adjust the depth of field, and you can adjust the focus, things like that. So that you can see here. Here on the left image, the focal distance is being changed from far away to really close up. And on the right, the aperture is being changed, which causes the depth of field to become really shallow or to include the whole image sharply. What you can also do of which I couldn't find any example images, sadly, is actually change your perspective effect afterwards. So you can change the image to have more or less of a perspective effect, which is really impressive to see. You could also calculate the distance of every pixel to the camera by seeing where the rays converge. You can calculate all that. And then you can remove the background without having to use a green screen or anything, like you see here in this animation. You can see this is the original background. It's being removed. And then you have the alpha channel, which defines the translucency of the foreground image. And then the background image is being replaced by a cloudy sky. And you can even use this to adjust motion blur or to stabilize the image afterwards. So here we see an example of motion blur, and even extreme motion blur that's not possible in with a physical camera. And you can all change that afterwards in post-production. And you can even change that while the image is moving. So the stabilization is real virtual optical stabilization. So it actually simulates a real stabilized lens, as if the camera had been actually stable without any artifacts of doing the stabilization only in 2 dimensions by moving the image around. But that's not all you can do with light fields. What you could also do is have a 3D stereoscopic image. If you are going to record that with a camera, you need a sensor that is as big as the distance between your eyes. Otherwise, you don't capture the natural depth information that you would normally see. But in this case, on the right, this is one of the holograms that I've rendered. And it simulates, or it has a wide enough angle range to be able to show with actual 3D depth. So this is really holographic 3D without having to wear any glasses or without any head tracking. Multiple people can look at it at the same time. And what you see happening here as well is the reflections, and especially visible the refractions, that actually correctly respond to your viewing angle. So as you move around the display, you can see the reflections move accordingly, and they also have correct 3D depth. So that is really impressive looking in real life. Another thing that you can do with light fields that you cannot do with normal stereoscopic 3D is when you have panoramic video, like 180 or 360 degrees 3D video, you don't have correct 3D in all directions. So it's only correct where the original stereo cameras were aiming at. Usually that's about 4 directions horizontally. And you cannot properly stitch that. So if you look diagonally, then the 3D depth is incorrect. And with light fields, we have all directions around us. So wherever you look, you always can look at the correct rays coming from that direction. So your 3D image stays correct. So what are some practical limitations currently? Well, storing or even generating thousands of rays in different directions per pixel is not practically possible because storage, performance, or physical limitations might limit it. In practice, we look at angular resolution when using a virtual lens. So we have like a lower field of view per pixel. You see that on the left in the little diagram here. And you talk about spatial resolution. There you have a higher field of view per pixel. When you use the light field for displaying holograms like you just saw, where you can kind of look around them. But usually those don't have a high enough resolution to also be able to actually focus on the image correctly. So what's another practical limitation currently? That is that the rays are limited in number. So the further away from the display they get, the more they start to diverge. And in extreme cases, then things happen like you can see on the right, where the whole image starts to break up in separate segments. So that's a limitation of having a limited amount of rays. But if you would really have massive amounts of rays, you couldn't just generate them in real time, or even rendering them would take forever. And storing them would take way too much data. So what are some ways of capturing light fields? We see here the first generation LiTRO camera, which I have as well. It's called a light field camera. It's also called a planoptic camera, this type of camera. And the first one of those was released in 1908 already. And it used a micro lens array as well. So that's pretty impressive. And the first commercial light field camera, which is this one, was released in 2012, and it cost between $400 and $500. I bought mine for €40 actually, new. It has a resolution of 11 megapixels, but those are divided by 10 by 10 rays. So it's about 100 rays per pixel for different directions, horizontally and vertically. And as you see, it has a really cool novel design, lots of different colors. And at the bottom right, you can see the micro lens array. It's hexagonally arranged to make optical use of the available space. And that is used to be able to capture the light coming in from all directions and divide it over the sensor of the camera. Now this model was followed up by the LiTRO Ilum, which I also have. I recently got one for a project I've been working on. This one was released in 2014. And the price at that time was $1,600, which is not what I paid for it. I paid a fraction of that. This model, as you can see, is much more professional looking. It has a massive lens. It weighs a ton as well. It has a resolution of 40 what they call mega rays, which is actually just 40 megapixels. And this resolution is divided by 14 by 14 ray directions per pixel. So that's almost 200 directions per pixel. And what you can do on the camera itself with its touchscreen is just change the focal length, the focal distance, by just pointing at a part of your picture, and then it will change where the focus is. And you can also use gestures, like a twisting gesture, to change your aperture. And this is all applied after taking photos, so you can just look at your gallery on the camera itself and then adjust your aperture and your focus. You can even move around the image a little bit in all directions that were captured. So these cameras all have a special type of lens because we want to preserve all the directions of the light rays coming in, which is, like I said, combined with a micro lens array. And you can see the one on the bottom right. There's very clearly the effect of the micro lenses. So they capture the images from a slightly different angle. And this way it uses multiple pixels per pixel to record the ray directions, which you see in the green grid above. There's a little yellow grid within that. And you can see where the directions per pixel are stored in the resulting image. So LiTRO's commercial cameras, like you just saw, they didn't find a large enough audience. And this was mostly because of the low effective resolution they have. So they have to store all these directions of light and divide the sensor, the amount of megapixels between that. So the resulting resolution is just about display resolution. So it's not suitable for, well, you could print it, but it would look, it wouldn't be very sharp. So professional photographers didn't like the low resolution it had. And then it becomes more of a novelty item. So you could post photos of it online, and then people looking at them could change the focal distance and everything. but this wasn't a large enough market to sell well. So Lytro changed to making professional studio cameras, like the one you see on the left here. This is the Lytro Emerge camera. This one was mostly made for being able to walk around in a very limited way within a 360 VR video. So you see a 3D video around you. You can move around a little bit, and the reflections and refractions around you, everything will respond naturally. So you feel like you're actually inside a recorded environment. Now the one on the bottom right was made for recording cinema footage. And the whole idea of that one is that you could do everything in post-production. So the depth of field, motion blur, the things you just saw, they were examples that were done with this camera. Removing the background, stabilizing. And this camera, both cameras came with an array of servers actually to be able to store the massive amount of data that they generate. And this is a follow-up of the Lytro Emerge you just saw, which is a much larger device. It's absolutely huge. And you can see that it's an array of a lot of cameras, also used for similar purposes, but you can see it's no longer a 360 camera. So Lytro was acquired by Google in 2018. And Raytrix cameras use similar technology. So you can still get light field cameras, but these are aimed at professional use, so they're even more expensive. And I couldn't find anything about it anymore, but I think they bought some of the patents of Lytro as well when it was bought. So talking about Google, they've been working on recording and displaying light field images and even videos for a while now. And this is one of their earlier setups. This is just a massive ring of, well, part of a ring of cameras that moves around. So this is not suitable for actually recording videos. This is for making light field photos, but as you can see, there are panorama shots. You can view the result of this camera, multiple light fields, in their free Welcome to Light Fields application, which you can download from SteamVR. And you can, or from Steam, I mean, and you can use this in VR. So you also have limited room to move around in. And it's actually really impressive looking. I can really recommend trying this because with this you can also see all the highlights and the reflections and everything just moving with you as you move around. You have a space of about a meter to move around in. So their current camera setup is made out of 46 cameras, and they can record videos. And even with the videos, you have some movement, some freedom of movement. So you can move around a little bit within the videos and look around all around you. And the videos from these cameras are combined using a deep learning algorithm. And they combine all the video footage into one light field video. And I have some more information about that later. And then there's a number of other solutions. You see the giant one at the left. And on the right, there's another of these impressive looking camera arrays. And this one is made by the Stanford University. So if you only want to record a horizontal light field, which are used for the displays I'm going to show next, then you could choose a camera rail. And the camera rail just records a sequence of frames, and that can be converted into a horizontal light field, which you can look around. So that's more of the hologram type of light field. And then there's other ways of creating light field images. You can render them in 3D software like Blender. This is what I've been doing a lot lately. I've been using the Alice Looking Glass plugin. Very hard to search for on Google. And for interactive applications, you can use Unity or Unreal Engine combined with a plugin. And then you can actually have interactive holograms, which are rendered in real time. So that's really impressive. Another option that you can use is just use your portrait photos from recent phones, because they store depth information as well. You have the iPhone with the LiDAR scanner on it. Some Android models also support adding depth maps, and you can already on your phone change the depth of field of the background and everything. Although that's not really based on the actual information of the rays falling on the sensor. That's just a combination of the photo and the depth map. And that's the way these hologram types are generated as well. You can see the photo on the left and then the depth map in the middle. And then you can see the result on one of the looking glass displays, which I'm going to be talking about next. The conversion from even from normal pictures, because that's also possible, can be done with machine learning. So you can even take photos from 100 years ago and make them into kind of a hologram. So what are some ways of experiencing light fields? Because we have recorded them, but now we want to look at them. So there's Looking Glass Factory, which was founded in 2014, and they released their first desktop holographic display in 2018. So that's not very long ago. I recently backed their Kickstarter campaign for an entry-level Looking Glass portrait display. This is the one you see in the photo here. I received this one a couple of weeks ago, and I've been busy creating some things for it, because it's a really cool device, and I only paid $200 for it. Super early bird price that was. So here you see two of the holograms I've been rendering using Blender with the plugin I just mentioned. And the aim with these holograms that I make is usually to include some interesting reflections and refraction that responds in an interesting way to the camera angle. So the one on the right is just a still, and the one on the left is very limited animation. And actually, this is a premiere because the one on the left I haven't released yet. So I'm releasing that this week. Another thing I made was using Unity with the Looking Glass plugin in combination with hand tracking with leap motion. So you can actually interact with the hologram and smash the balls around the court. This was based on a famous Boing ball demo from the Amiga computers, which was one thing that was a demo that was used to show off their prototype. So someone asked if such a thing could be done, and I thought, yeah, I could easily do that with Unity. What I also developed was a simple utility to convert 3D photos to the Looking Glass display, which actually converts the display to a standard 3D display. So you cannot look around the image like you would with a real hologram, but it will show you the image in 3D if you're looking exactly from the sweet spot of the display. But it's a nice, easy solution to be able to see your 3D photos on it. And what you see here is on the left is a project I've been working on to show Lytro images on the Looking Glass display. Now the thing here is the Lytro cameras use the angular light fields. So they have a very limited field of view, and they're really aimed at doing refocusing after taking an image. While the Lytro or the Looking Glass display is really aimed at holograms. So it has nothing to do with depth of field or anything, but everything to do with 3D and looking around the image. So as you can see on the right, I have the light field of the Lytro camera responding to the viewing angle. So you see a little bit of parallax effect happening there from the depth information. But you also see that the image is contained within a small circle. And that is because that's all the information that has been captured by the camera. You could vary this, but then you get less of a depth effect in it. So that's still a bit of an interesting project to see if there's actually anything useful that's going to come out of that. This all works with a custom shader I wrote to convert the light field images and to make everything respond to the viewing angles and interpolate all the information to make everything smooth. So as you see on the image at the right, it moves very slightly, and that's just selecting one direction from all the pixels at a time. So this is all from the first generation camera, and the Lytro Ilum camera has some more range. So there are different models of looking glass displays, and they have models all the way up to a very expensive 30-inch 8K display, which is the one you can see on the right. And these versions have a large slab of acrylic on them, which is no longer needed with the portrait one. So how do these types of displays work? Because they don't require wearing any glasses and they don't use any head tracking. Well, for viewing 3D images without glasses, there's two solutions. You see the one at the top is called parallax barrier, and it blocks images from your left and right eye accordingly. So the left eye sees a different image than the right eye, and in this way you can show a 3D image. This is actually what's used on the Nintendo 3DS. And at the bottom you see a lenticular screen. So it has a layer that's similar to the micro lenses, but it's only in one direction, which has the same effect. Well, most people will know these little ribbed cards that when you move them, you look from a different angle, then the image changes. And these cards come in 3D variants as well. So here you can see that the technology can be used to show 3D. This is also what my 3D camera uses on its display, which you can see at the top right. It's a Fujifilm camera. This works quite well, but you can only see it properly from a few viewing angles. So it has a couple of sweet spots where the image is correct, and from other positions it's inverted or just jumbled. Now, if you add more images per rib of this lenticular display, then you can see more images from different directions. And you can buy cards that actually do that as well. So the one you see at the bottom left is one that you see a lot in stores. So this is also what is used to show holograms. And this is what the looking glass display, how the looking glass display does its thing, because it's only displaying horizontal light field rays. If you look from above or below it, nothing happens. The image actually is not correct then. The idea behind this is that you're more likely to look around horizontally, especially when you have it just on your desk. But also to save on performance, which is a very smart thing, performance in both storage and performance. And an interesting thing they do is they have a slanted lenticular layer on the display. So you can see that on the right. The effect of that is that you also convert your vertical resolution of your display into horizontal light rays. So in that way, you're really using your display optimally for a maximum amount of rays horizontally. And even the subpixels of this display each have their own direction, like the RGB subpixels. And the looking glass display can handle up to 100 viewing directions, and that is within a range of 50 degrees horizontally. Now, another variation on this technique is used for the Leia Loom pad, and that is actually just a a tablet like everyone is used to, but it has a very special lenticular layer on it, which allows you to see images in 3D. Optionally with 4 viewing directions, so it doesn't have many directions. But the interesting thing about this is that you can view the image in 3D both in landscape and in portrait orientation. So that makes it kind of different than the other solutions. Then there's a company called Dimenco, and that's a company in the Netherlands. I visited this company with a couple of my colleagues some time ago. And they've created a solution that they call simulated reality. And it is a form of desktop AR. So we have AR with headsets, and then there's something called desktop AR, which uses a 3D monitor, usually in combination with a form of hand tracking. So you can do similar things to what you can do with a HoloLens, for instance, but it's just that you're sitting at a desk behind the monitor, but you still see holograms floating in front of you. One user can view the display at a time. That's one limitation of this, because this uses a regular 3D, autostereoscopic 3D display. So they use a lenticular layer for stereo 3D, but they have camera tracking, so you can still look around the object. One advantage of that is that when the image gets further away from the screen, it doesn't break up in separate rays, so it stays sharp. That's one major advantage of it. And also that the resolution of the image can be higher because you're not dividing it over a lot of different directions at the same time. But multiple users cannot look at the display at the same time and see your correct image. Also, Acer just recently announced that they're going to be releasing a laptop that uses this technology. So it's really doing well. They just had funding from a well-known company in the Netherlands, 2.5 million euro funding. So desktop AR is really an interesting development besides the headsets that we're used to. So to quickly show, the Menko solution is really similar to a solution I had been working on, which uses a regular stereoscopic display. So this is just my 3D television on the left, which uses normal cinema glasses, and my 3D monitor on the right. I'm using a combination of Kinect or infrared head tracking to track where the user is looking from. And I use it in combination with leap motion hand tracking. What you see on the right has been filmed from a different direction than where my eyes were. But in reality, you're actually grabbing the hologram that you see in front of you, and you can manipulate it like you see here in the little animation. And then Sony also recently came out with their spatial reality display. It is very similar to Dimenco's solution. So as you can see on the left, it also uses a lenticular display, and it also uses head tracking. You see the camera at the top of the display there. But it doesn't use any form of hand interaction. And you actually can buy this display. It's pretty expensive though. Now, apart from working on their light field cameras, Google recently announced something called Project Starline. Now, the idea of that is that people can communicate with each other all over the world. And they will see each other in the form of a hologram on a light field display. So they have some way of recording people as a hologram. And I'm not sure if they're using an array of cameras or if they're using a depth camera like the Kinect is. But in this way, they will show a more natural way of interaction. You can actually look each other in the eyes, a bit like with Microsoft Mesh, but then you can see the actual image of the person in 3D. And this idea is actually very similar to the idea that Looking Glass had with their Looking Glass portrait display, as you can see at the top right. You can use it in combination with an Azure Kinect to create kind of a live hologram of yourself. And the idea was also that you could communicate with other people and you would see them in the form of a hologram. Now, many of you will remember this video. So this shows what the Magic Leap headset would be able to deliver. This is a massive hologram inside like a gym or something. And this is what it looked like in practice. So it's much smaller than what we see here, but still not bad looking actually. And this guy was really happy with the result. So you see the resulting headset on the left. You probably know it already. It's a bit smaller than the HoloLens, but not much more advanced. One of the most hyped aspects of it was support for light fields. And that, they said, would be a giant leap in realism. And I was very skeptical of this claim, as generating light fields like we just talked about, especially in real time, it requires a lot of processing power. And if you are going to do this on a mobile device, then it gets really difficult. So in the end, the Magic Leap only supports 2 different focal distances. And I do this by actually packing 2 displays on top of each other, with each with their own projection. Now, what are some developments that are going to happen in the future? What is being worked on currently? So one of the problems is the large storage that is needed for light fields. And Google has been working on that. And they've created a system that converts light field video, like you see with their 46 camera rig over there, into concentric mesh layers. So there are like spheres around you that increase in diameter, and they have transparent textures on them. So then you get like the parallax effect when you move around in the sphere, and everything looks like it is 3D. And they can compress this with existing compression techniques for video, which is a big advantage of it. And they can use texture atlasing also to get repeating, to store repeating parts only once, and probably get rid of empty areas and everything like that. And what this could do is even stream panoramic light field videos. So you could stream one like you would do on YouTube, but you will be able to move around a little bit in it, look all around you, and have really a much more convincing view of the recording than you would with a regular 3D 360 video. And below you can see a bit of the pipeline, how they convert everything to be able to do that. So one thing that has been a problem with 3D displays, and that's also for 3D cinema virtual mixed reality headsets, that's called the Virgin's accommodation conflict. So a 3D scene is always just displayed on a flat screen, but while you're aiming your eyes at an object that might be right in front of you or behind the screen even, you still need to keep focusing on the display, because if you stop doing that, then everything will go out of focus. And this is a very unnatural thing to do, because you usually always focus on the thing that your eyes are aiming at as well. And this is also a reason why people get a headache initially when they watch 3D cinema, for instance. They complain that they get a headache because their brain is learning something new that is quite unnatural. And this is partly solved by the Magic Leap, which has the 2 focal distances, like I said, but it would be even better if there were more distances that you could focus at. So that's also something that's being worked on. That is a little array of micro lenses, like you see here, called MLA, micro lens array. But it's very close up to your eye, and it's inside a headset, like a virtual reality or augmented reality headset. And in this way, it allows you to focus on every distance that objects are, instead of a set focal distance which the headsets have now. So they always have like a few meters away, or often 1 or 2 meters away, set focal distance. So that would make everything much more natural, and you would focus on one point, and all the other objects at different distances would get out of focus. It would also allow you to look around the image without moving your head, and then the 3D, the depth information is still correct because it has all the light ray directions correctly for every direction you are viewing it in, which is also not currently the case. If you look around in the virtual image, then the depth information is not always correct, just like with the 3D 360 videos I mentioned before. So on the top right, you see an actual physical model that's being worked on with 2 light field displays inside of it. So I think this is going to be the future of virtual and augmented reality headsets. Especially with augmented reality, it would make the holograms that you see around you in the real environment much more natural. So you focus on the physical item, and your hologram will still also be correctly in focus. And that's not the case right now. So I think light fields are really the future of displaying and recording computer graphics. And with advances in compression of them, I think that there will become a much more common solution very soon. So that was my talk about light fields. I hope you learned something. Sometimes a bit hard to explain everything because it is a pretty large topic actually. You can do a lot of things with light fields, and I hope I have made you a bit enthusiastic about them. If you have any questions, I'd love to hear them. At the bottom right, there's a link to my YouTube channel if you're interested in seeing releases of my holograms and other stuff I work on, or you can connect to me on LinkedIn. So thank you for watching my presentation.
So great session.
Thank you so much. That was really interesting.
Interesting topic, difficult topic.
Yeah.
But very interesting. Yeah. We don't have any questions from the audience, but we made up some ourselves, of course. Okay, so you showed us some different cameras where you can create light fields with. But if you want to get started with that, which camera is best and also a bit affordable?
Right. So at the moment, that is a bit of a difficult thing because, of course, Lytro is now part of Google, and Google is creating things that you cannot buy. I actually have the Lytro cameras nearby here. So I have the small one here. This is actually the most affordable way if you want to get into creating light field photos. The results are actually pretty good because I can compare them to the much more expensive camera, which is much less expensive nowadays. But so this is the Ilum that I just showed. It's quite huge. It's not really all that portable. So I would suggest starting with the first model. And you can still do the refocus thing and everything. The only thing that doesn't work anymore is sharing online with Lytro's own service. But you can still use them in the application. You can even create animations with it where the focus changes and everything. You can look around a little bit. So yeah, that would be my suggestion because the other solutions are really expensive. And these you can get between 50 and 80 euros, I think, secondhand.
Okay. And then let's say I bought that first generation, that camera. And then what kind of software do I use to get started with projects, or what can you recommend?
Yeah, so the included software is all you need to be able to do the refocusing and everything. Luckily, there's a still active community behind it that's saved all the software that you would normally get for free. So you can still get that, and it still all works. So you can use that for the functionality that was originally included. and then to be able to get some more out of it, because there's no way to actually display the light field. And that's very puzzling, because I think it would have been much more of a success if they actually released a display at the same time that was able to display the light fields the way you recorded them. And that didn't happen, so I think that was part of why it failed. So what I've been working on is trying to display these light fields on the looking glass displays, so you can at least experience them a little bit as they were originally recorded. But that's at the moment, that's still a work in progress. So before I can release that, it needs to be user-friendly and everything. But I can highly recommend, I can show it, it's here next to me as well. So this is my looking glass portrait. And I got this for $200. And the previous model was $600, I think. So that's already a lot cheaper. And I think you can get them for about $250 right now. So I can highly recommend that if you want to get into light fields, especially if you're already working with 3D software like Blender or maybe Unity or Unreal Engine, then it is very easy to start creating light fields with that as well.
Okay, sounds good. I will definitely check that out. And are you working on projects for clients with this technology as well?
We're not doing any projects for clients at the moment that use light fields. So I'm currently working together with Saskia on VR simulation for medical training for the military. So that's something completely different.
Also very important.
Yeah, it's very interesting. Yeah, it's a very good project because you can normally not do training like that in real life. It's like a war situation and everything. I've also been working on remastering some of my very first professional animations that I made when I worked at Davilex, which the games were called Red Cat. That was the main star, and it's a typically Dutch thing, so Dutch people recognize it, and Saskia also didn't recognize it. So, but I've now been doing HD remasters of them, and they were originally low-res animations in 256 colors. So that's also a cool project. But I have to say that creating holograms is really addicting, because they're always, if you have a good idea, then you start to wonder what would it look like as a hologram, and then you just have to make it to see the results.
So speaking, that's actually a good point, because I have a question. Talking about holograms, right? All the displays and the cameras you now introduced, they're all like kind of lens-based. But many people, when they think hologram, right, they think of a different kind of hologram that you sometimes see like in old museums and stuff. And they're not based on lenses, they're based on diffraction gratings, interference patterns, and they have like super high resolutions. So my question is, how do the displays that you now like see compare to that, resolution-wise and in other regards? And second question, do you know if there's any recent developments in making holographic displays based on diffraction?
Well, it's an interesting question, because people often get angry when you talk about holograms, and they keep on saying, well, that's not a hologram. And of course, where that started was, I think, with the HoloLens, where they started calling everything holograms. And then people got upset because they were not traditional holograms, so you couldn't call them that. From the holograms that I have, I've had for a long time already, are a higher resolution than the ones you can show on the displays, because of the technical limitations, everything from the bandwidth and performance and everything. What I forgot to mention is you usually see multiple rays at once, so you cannot simply divide the resolution by the number of views you have to say, okay, but then I'm only left with this low resolution, because you see about 4 or more rays at the same time, so the perceived resolution is actually a bit higher. You do also have traditional holograms that have color, so the result is very similar. Of course, they are never interactive, which is a big advantage of a regular display. And what I've seen as a technology, but I don't see it much in practice, is that they actually aim the backlight in different directions. So from what I know about traditional holograms, I don't know very much about them, but that is kind of similar because they have directions like holes in them in different directions, I think, and that causes the whole pattern that you see. So they have backlights that are based on that idea, that just shine light in certain directions, but I haven't seen anything practical come out of that yet.
Okay.
So,
Well, I remember from that was like years ago that they actually were working on that, actually
yeah.
like creating this diffraction grating artificially. But already back then it took like a long time, huge amounts of data, but I also haven't seen any recent developments in that area. Would be interesting.
Yeah, and that's actually something I noticed while doing research for this presentation, that a lot of things that I encountered that had to do with light fields, they were all discontinued. So I was wondering when the light show cameras fail to sell well, if a lot of these parties like Adobe and other well-known companies gave up on the idea of going further with those developments. So that's a bit of a shame, because I really do see it as the future of display technology, because it
Yes, and
fixes all the
also
problems of regular 3D displays.
virtual reality. I don't know
Yeah,
if you can
absolutely. The next step to make it much more natural. And what you
take
could do,
a picture of your vacation spot and then walk through it again.
yeah, absolutely. Because one thing I heard is that even 3D images trigger your memory much more than the 2D images of places where you've been. So the more convincing the experience is, like you got a surround image, it's 3D, and then eventually light fields where it's even more natural, that triggers your memory much more than just watching a photo.
Yeah.
So yeah, that would
Awesome.
be
Well, Milan, thank you so much. Unfortunately, I would love to
okay.
talk
You're
to you
welcome.
more. We are out of time. Thank you so much. It was a really great and interesting talk.
Yeah,
Thank you.
definitely.
I enjoyed doing the presentation.
Great.
Thank you so
Okay,
much.
thanks.
All right.
Bye-bye.
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 So then next is Victoria, right?
Yeah, but shall we have I think we have a little video.
Oh
Shall we
yes, of
start with
course.
Victoria?
No. First, we do the video of the global XR conference. There we go. So, and we're back. So it's time to add Victoria to the screen, our next speaker, and she's going to talk about extended reality NFTs. So, hi, Victoria.
Welcome, Victoria.
Hello.
Great that you are here. So, how are you?
Oh, I'm doing very well. But hang on, I must. There you go. That's better now.
Sounds better, yeah.
Yeah, I'm doing well. I'm just in my studio. Yeah, I had a video. I decided that I wanted to do a mixed reality video instead of doing it live. Just like really quickly put on my costume again so that everything could match the video.
Okay.
Well, we're super excited to have you again because you've been a speaker with us before.
Yeah.
And do you want to introduce yourself, or shall we do it? Because you have done so many things, right? You're a developer, you're an artist, you have won an Emmy.
Yes.
Tell us a bit about that.
Oh, yeah.
So I like to keep myself very busy. I like to do a lot of different things. I've been a developer since I was 10 years old. I started out by teaching myself web development. I taught myself HTML, and I taught myself CSS, and that just kickstarted my career. I went through the motions and became an email marketing expert, and then database specialist, then an API developer, then a full stack web developer, then an XR developer when I started in Unity. And I won an Emmy by working with my favorite artist in the entire world, Joe Gordon-Levitt. He has an artist community online called Hit Record, and I've been a member of it for, I want to say 10 years now. And in 2013, we started production on a TV show called Hit Record on TV. It was just something that I did with my nerdy friends at Hit Record, right? Like, we didn't really think anything of it. We were just like, oh, this is cool. We're making like TV show, and we're making TV show about games and about fantasies and about space. And then the very next year, we ended up winning an Emmy for it. And I was like, oh, I was just hanging out with my friends, but like now I have an Emmy to show for it. That's pretty cool. So if you want to see my face, I did a lot for this show. I was an actress, I was a dancer, and I was an illustrator and an animator too. But if you want to see my face, you could catch me in season 1, episode 8 regarding games, or sorry, episode 6 regarding games. And you will see me speaking Japanese. You'll see me telling really bad jokes. In season 2, you'll also find me dancing like a goth in a forest with everyone. This is a lot of fun.
Amazing. My God, you did so many things. Unbelievable. And also your topic, right? Last time you were with us, you talked about projection mapping. Mm-hmm. And today your topic is yet again something completely different. You're going to talk about NFTs.
Yes. I fell in love with NFTs. I got into it because somebody found my mixed reality work, and they approached me and they're like, I want to buy this as an NFT. And I didn't know what an NFT was at the time. I was just really happy that somebody wanted to buy my art because I'm a software developer, right? That's the way I've made the majority of my money throughout the majority of my life. I never thought that anyone would actually want to pay me for art. I just did art because it was fun. But he bought an NFT, and then a bunch of other people bought NFTs. It seemed like my augmented reality and my virtual reality and my mixed reality, like my cross reality NFTs, a lot of people seem to really like them. And I'm working on a new set of VR and AR NFTs that are done exclusively in WebXR. And I'm really, really excited for this. And the space is growing. There's a lot of unique and interesting things that people are doing with NFTs, where they're not just minting, just JPEGs or GIFs of 3D models. You have people that are minting like gorgeous paintings. There's actually a project where a woman is actually selling houses by NFTs, where somebody buys an NFT for a reasonable price, and she has it that's actually connected to a real estate. So these people buy this NFT off of the blockchain, and now they have a house. So
wow.
The utility of NFTs is crazy, and I deep dive into the technical specifics, as well as a variety of different ways that you can utilize these NFTs in a lot of other areas that is not just art.
Awesome. That sounds super interesting. This whole world is completely new to me, so I have no idea. So I'm super excited to hear your talk.
Yeah, me too. And you are going to show a video. Your whole session is a video, right? So that's the only thing that I have to show. Yeah?
Yep,
Okay,
just the
let's
video.
go for it then. Okay.
Hello, world. I'm Victoria, and I'm a hardcore cosplay nerd that loves computers, and I'm here to talk to you about the future. Future of extended reality and NFTs. Now, I know you've seen the headlines. You've heard about the buttload of money that's being tossed around towards this acronym called an NFT. So what the heck is an NFT? What the heck does it have to do with extended reality anyway? We'll find out the answer to those questions and more right now. So what the heck is an NFT? An NFT stands for a non-fungible token. A non-fungible token is a unique identifier that is used to represent a piece of data stored on a digital ledger called a blockchain that certifies an asset to be unique. A digital certificate of authenticity, if you will. Non-fungibility refers to the fact that it is not interchangeable with another token because each token is unique and indivisible. Bitcoin, for example, is fungible because each Bitcoin can be broken apart into smaller pieces and each are interchangeable with the other. For example, one Bitcoin is like another Bitcoin, and they can each be broken down into smaller pieces like 0.5 of a Bitcoin, etc. Therefore, it is fungible, identical to each other, divisible, and worth exactly the same. An NFT is a unique identifier on a blockchain and cannot turn into 0.5 of an NFT. It remains intact, therefore, it is non-fungible. An NFT is on a blockchain, but not all blockchains can have NFTs. Going back to Bitcoin, the Bitcoin blockchain is incapable of NFTs because that just wasn't built into the technology. Other blockchains, such as Ethereum, have token standards built in. So what the heck is this word? Keep hearing it everywhere. Blockchain, blockchain, blockchain. What the heck is a blockchain? Well, I got you, fam. A blockchain is a type of database. And a database is a collection of data that is stored electronically on a computer system. Most traditional databases structure data in a centralized way using tables with rows and columns that make it easy to filter through and retrieve information. Think of it as a giant Excel spreadsheet. If you have a basic understanding of an Excel spreadsheet, then you have a basic understanding of most traditional databases. Now, circling back to blockchains. Blockchains store data entirely differently from ye olde centralized databases. Now, let's take a look at a blockchain. A blockchain uses a Merkle tree data structure and it collects data in groups, known as blocks. Merkle trees are basically binary trees that contain cryptographic hashes, and these blocks have limited storage capacities. When filled, they're then chained onto the previously filled block, forming a chain of data, and that's what's called the blockchain. Any new piece of data that follows that newly added block is then compiled into a newly formed block that will then also be added to the chain, and thus it continues. So, to recap, traditional databases store data into large centralized tables, and a blockchain structures data into cryptographic hash binary trees. See these things. And blocks that are chained together. All blockchains are databases, but not all databases are blockchains. The Ethereum blockchain is the most used blockchain for NFTs and was the originating blockchain for the ERC 721 smart contract standard. ERC token standards run on the Ethereum blockchain, and there are several fungible and non-fungible token standards available on Ethereum. Now let's talk about Ethereum smart contract standards. Yay! Let's start with fungible tokens. ERC20, first proposed in 2015, is the industry standard and the most accepted. It makes the initial distribution of tokens extremely easy, so it gained a massive adoption. This basically simplifies the transfer and reduces it to just one single step, which makes the process way cheaper. Way less gas fees, which is blockchain talk for transaction fees. ERC 827s, they combine some of the advantages of the ERC 223 and ERC 20 standards. It enables token transfer for a third party to spend it. ERC 664 is mainly centered on modularity, and it makes it possible to update token contracts. ERC 827 combines some of the advantages of ERC 223 and ERC 20 standards. It enables token transfer for a third party to spend it. ERC 664 is mainly centered on modularity, and it makes it possible to update token contracts. ERC 677 provides a safe way for new contracts to transfer tokens to external contracts. ERC 621 can increase or decrease the token supply. ERC 884 allows companies to use blockchain to maintain and share registries. Yes, now we have reached the non-fungible token standards. The mighty ERC 721 was the first standardized interface for creating NFTs, and it is the most popular by far. It's immutable, which means it cannot be changed, and it's extremely transparent in ownership and security. It is a true NFT. It cannot be divided. It represents a single transferable asset. And it's great for creating and tracking unique NFTs. The primary drawback is that this one uses up a lot of gas, which are transaction fees. And those are fees that are paid to the miners for their wonderful efforts in mining our beautiful, beautiful ETH. If you plan on minting a lot of smart contracts onto the blockchain, you're probably not going to have a good time with an ERC 721. I'm just saying, there's better options out there. Speaking of which, the ERC 1155 tokens support non-fungible and fungible tokens. It's developed by Engine, and I still have all of my Engine shirts from the last few GDCs. And it's known as the next generation multi-token standard. ERC 1155s can use a single contract to make several types of NFTs, and gas fees are significantly less. I mean, they're cut by probably about 90%, and it's an extremely affordable standard. The biggest drawback is that the provenance on these ain't so good. They're a lot harder to track because the specifications in the Ethereum logs have way less information available. So what the heck is a proof-of-work blockchain? Proof-of-work blockchains require solving complex mathematical problems as a way of verifying the legitimacy of transactions on the network. We call this mining. These problems are computationally expensive and therefore require large amounts of energy and an extremely powerful computer. All the network miners compete to be the first to solve these puzzles through brute force. Now, these puzzles are extremely energy intensive. Frankly, they're not the most environmentally sound. But proof of stake, on the other hand, consensus mechanism completely virtual. While the process remains mostly the same as proof of work, the method of reaching the end goal is entirely different. In proof of stake, instead of miners, there are validators. The validators lock up some of their ether as a stake in the ecosystem. Following that, the validators bet on the blocks that they feel will be added next to the chain. When the block gets added, the validators get a block reward in proportion to their stake. So now that we have a basic understanding of what a blockchain is, how proof of work versus proof of stake work, and what NFTs actually are. Let's talk about extended reality and how these tokens can solve some pain points through their utility in the metaverse and beyond. Now, I admit I made the title of this talk a little clickbaity. NFTs are so much more than just tokenized art. These decentralized, immutable, programmable, unique identifiers can be attached to anything. They could be attached to a physical structure, like a sculpture or a painting. They could be attached to a piece of virtual art, or it could be attached to a ticket to a virtual or real-life event. It could even be a virtual item for your avatar in your metaverse closet. These tokens provide amazing utility because they show true ownership, they have provable scarcity, provable provenance, permanence, programmability, and decentralization. That was a mouthful. So let's talk about the thing that you've been hearing about the most, NFTs in the traditional art world. Now, NFTs have been quite disruptive in the traditional fine art world over the last few months, with characters such as people selling NFTs for millions of dollars, and collectible characters such as the CryptoPunks and CryptoKitties that have a limited run and are randomly generated using custom-built software. All kinds of traditional artists are flocking to NFTs, from photographers to painters to 3D modelers, because of the provenance feature of the smart contract structure. Provenance is just a fancy way of saying the origin of a thing. In the old days of art collecting, once an artist sells their work to one collector, that collector could resell that art for 100 times more, for 1 billion times more. They could do what they want. And unfortunately, the artist doesn't get the opportunity to partake in the resale of their creation. By writing a smart contract that protects the artist could continue to see residuals on their hard work for the rest of their life and beyond. The transparent nature of the blockchain also allows artists to be completely free of middlemen, because at the end of the day, they're able to directly connect to their buyers and stay connected through the programmable nature of the NFT smart contracts. So what about NFTs and XR and the metaverse? To quote my friend John Radoff from Beamable, social acceptability means trust. That your counterparties in transactions, relationships, and experiences will also treat it as real. NFTs can provide the metaverse a unique creator economy. Through NFTs, as the transparent nature of the blockchain leads to increased trust. People tend to buy things from people that they trust. In metaverses like CryptoVoxels and Decentraland, you're able to purchase parcels of virtual land through NFTs. These NFTs provide a level of trust that a person in the metaverse could feel compelled to purchase a plot just because they trust in that metaverse. They trust it enough to invest in it, and they trust that their friends will be there hanging out, greet them, have virtual pizza on Bitcoin Pizza Day. Shout out Pizza DAO! Basically, they trust in the provenance of the plot. And since you're able to see a record of every transaction and can trace the person or people who have owned something in the past, it leads to some items gaining value, not because of scarcity or utility, but because of who held them in the past. If a popular esports personality or celebrity owned a rare item, you'd bet that item would be most definitely one of the most highly sought after. As I said before, NFTs also provide the creator a permanent link to their collector by way of the digital ledger records and programmability. To expand on that thought, imagine that you are playing an interactive trading card game that can act as an augmented reality version of a game similar to Yu-Gi-Oh! And that NFT allows a developer the ability to programmatically update the AR over time, thus offering continuous replayability and the warm, fuzzy feeling of knowing that you'll always be connected to this artist. Well, at least as long as you keep the NFT in your wallet. NFTs can provide some solutions to challenges in traditional garment supply chains. Traditional manufacturing supply chains are extremely fragmented and rely on complex global supply networks. It's an extremely resource-intensive job to keep track of so many things passing through so many channels. NFTs mitigate this pain point by leveraging the provable provenance aspect of these smart contracts. It's also a sustainability solution too. By being able to create and distribute virtual garments, fashion designers have the unique ability to make any type of virtual wearable. When leveraging the digital nature of NFTs, you're able to cut down on raw materials by creating anything from augmented reality jewelry to virtual reality dresses. Designers can be as creative and as prolific as they want without having to worry about the environmental and social impact of seasonal mass-produced garments. But the most important piece of this puzzle is the smart contract itself. The programmability that's offered allows the artists to have complete sovereignty. They make the rules on how they wish their art to be handled and where the token's royalties in the future should go, if the token were ever to be sold again. It also offers the ability to add multiple people as originators and stakeholders in order to credit individuals and distribute automated payouts accordingly. You can also program in intellectual property rights to your assets if you'd like. Just to note though, buying an NFT, unless otherwise stated in the smart contract code, does not give you IP rights. And local laws still apply. Decentralization offers an experience that is not subject to a middleman. It gives the power back to the creators because everything can be traced through the blockchain and items can be purchased directly from the creator's crypto wallet. This gives incredible power back to the community and strengthens the creator economy by giving each individual a larger stake. So how do I make an NFT? Well, there are various ways to make NFTs. It all depends on if you're writing your own smart contract or whether you're using a marketplace. For today's purposes, let's quickly mint an NFT on screensaver.world, a proof-of-stake and environmentally friendly marketplace that's on the Polygon Matic blockchain. Alrighty, let's get started. Let's connect our MetaMask wallet and switch to Polygon. And now we're ready to mint our first piece. Now go to the upper right-hand side of the screen to the box with the three little lines, and when the menu pops up, click on Mint. Press this click to upload. You could upload a PNG, JPEG, GLB, MP3, MP4, or GIF. These files are going to be hosted on IPFS, Interplanetary File System. Now, let's choose a file to mint. Let's see. Do I want this one or that one? All right, picked my favorite. Now I'm going to give it a title, calling it Metaverses. And I am going to fill in the description. I think my description is going to be mixed reality from another dimension. That seems pretty appropriate for me. Now I'm going to add tags so that my NFTs could be found. VR, virtual reality, mixed reality, model, because I am the model, cosplay, because I am most certainly cosplaying, but what's new? And photography, because this is a photograph. Now let's hit the preview button. We are almost there. All right. We've got all the information. We've got the picture. We've got my description, my title, my ETH wallet address, the date of the minting, the type of file, and the metadata. Now let's click on the mint button and make this official. Go! Now it's just a waiting game. Wait until this gets minted onto the blockchain. Now, occasionally, the transaction could fail, in which case you've unfortunately lost your gas fees. So if you want to try to mint again, you're going to have to double pay. That is unfortunate, but it's why I always recommend not to choose the cheapest minting option if you could help it. The slower the transaction goes, the higher of a possibility it has of failing and you double spending at the end of the day. So I haven't set this for sale yet, but I'm gonna. Just checking it all out, making sure everything's okay. And here we go. Let's make it official. I'm sitting with my fingers crossed, hoping that the transaction does not fail on me. On, go blockchain, go Polygon, go, go Polygon, go, go Polygon, go. I believe in you. I believe in all of your staked coins. Woohoo! Mission complete. Moon landing Successful. We've officially minted something onto the Polygon-matic blockchain. Okay, now you know how to mint an NFT on an environmentally friendly blockchain. And this all sounds really interesting, doesn't it? How about protecting ourselves and our art? Well, unfortunately, counterfeit art is everywhere, even in the physical space. While there's no stopping human nature, if that item in question is minted onto a marketplace, you can contact them and they'll take it down. But if they took the time to write a custom smart contract, then I would seek some sort of legal advice from a professional. But we are in such an amazing and important moment in time. Government hasn't cracked down yet. They're about to. We have the ability and the time to be able to write our own frameworks and standards for a better blockchain experience, an experience that's safe for everyone on the blockchain, every miner, every coin holder, any NFT hodler. We have the opportunity to change things. Well, that's all I got for you. This is a 101 course, after all, teaching you the basics, just letting you know what's possible, allowing your mind to be a little creative and start to dream up a better future for me, for you, for guys, gals, and our non-binary pals. Thank you so much for listening to me talk about nerdy stuff in cosplay. Appreciate you, and I will see you at the next Global XR Bootcamp. Bye, y'all.
Oh,
Wow.
thank you so much.
Thank you for having me.
That was great. A little overwhelming. I have like so many new words, minting. I don't know.
It is
Yeah.
But I really admire the way you can explain kind of all those complex things in kind of ways that make it understandable for us who are completely new to this. So that was great. Thank you so much. So now I'm left with a lot of questions. But so basically, NFTs are a way to help if you're an artist and you have digital art. They help you to sell your art, but also protect your art from copycats, right? And so if I was an artist and I had a digital artwork and I wanted to market it in this way and protect it in this way, how would I get started? I mean, you just showed us an example how to basically put your art onto the blockchain. Is that correct?
Yes.
Sorry. And but is that all I have to do, or like are there fees involved? Do I have to what do I have to do to get started?
So on marketplaces, they typically do charge a fee anywhere between 5% and 15%. But that has nothing to do with IP rights. When you put an NFT out there, it's the same thing as if you were selling a t-shirt. Somebody could buy that t-shirt, but the design, it still remains your intellectual property, unless you write out IP rights within the smart contract. That needs to be part of the NFT sale. Like if you buy this NFT, then you also get the IP rights to it. A perfect example is there's this NFT project called the Bored Ape Yacht Club. And with every Bored Ape, and they only made a run of 10,000, If you bought an original Bored Ape, you have the intellectual property rights to that ape. So you could do whatever you want with it. You could make derivatives and sell those as NFTs. You could take the ape and you could turn it into a cartoon character and animate it. You could take that ape and you could make him into a 3D model and put him in a game. But you only have that IP as long as you are a Bored Ape Yacht Club holder. If you were to sell the Bored Ape, or if you were to burn it, and burning basically means deleting, except you're not actually deleting it, you're sending it to an anonymous wallet, because nothing could be deleted off of the blockchain, it's immutable. But if you burn it and send it to that private anonymous wallet, you no longer own the IP rights to that Bored Ape. And recently in the NFT community, people have been burning or selling their Bored Apes while still making and selling derivatives of those apes. And they've been getting DMCA takedowns from the Bored Ape Yacht Club. So you need to be very, very specific and be very clear in defining what you as an artist want to get out of that sale. And that's what makes these smart contracts so important. They're not legal contracts. They're literally just code. But within that code, you could set whatever you want. And it's very, very important that you don't just do some kind of a default smart contract, especially if you have a very specific type of art and you want to be compensated a very specific way, or if it was a collaboration and you want multiple people to be compensated. You need to be very mindful about what you put into that smart contract, because once again, it is immutable. You can't change it. It is what it is, and it's going to stay that way on the blockchain forever.
Interesting. And as an art collector, you buy the NFT and then you own it, and then is it stored on your computer, or is it stored in the cloud, or?
So typically when you're using a marketplace, let's use OpenSea. It's an Ethereum marketplace, right? If you were to mint it on OpenSea, it would be hosted on something called IPFS, Interplanetary File System. And that's where your actual like 3D files or your JPEGs or your movie files or audio files, whatever, that gets stored there. But the unique token, the NFT itself, that goes onto the blockchain. Mm-hmm. So for example, one of my collectors, he bought an augmented reality wearable from me. And he wanted to actually get access to the 3D model to put into his virtual reality NFT gallery. Technically, like he only had the AR version of it, but because, we have a relationship, I gave him the 3D file. I was just like, okay, here you go. But that's, that's a one-on-one thing between the artist and the collector. It's typically it's typically a really good thing to keep in contact and build a relationship with your collectors, not only because they're customers and you want to keep a customer happy, but also because of the relationship with the art. They might have a request, and once again, due to the programmable nature of these NFTs, you could program within the smart contract changes ever so often, right? Like having that relationship with the collector, you could be like, hey, I just threw up an update to one of my AR NFTs. So go and check it out and have a whole new experience.
So you can actually change your NFT, like the piece of software that is the NFT, you can change it.
Yep.
Cool. So as the collector, then you're basically surprised by that the piece of art you bought has changed.
Yeah.
That's interesting. That's a really cool concept.
I think
so
that quite often.
Yeah, you do that. So yeah, that's so you for you as an artist, what's the biggest draw for like using NFTs instead of like traditionally selling your art?
The provenance and being able to get royalties off of the secondary market, because in the traditional art world, the artist does not see a dime when it comes to the secondary market. They sell it and then Godspeed. But if, for example, my collector who bought that AR NFT, if he were tomorrow to turn around and flip it for, he bought it for 0.5 ETH. Let's say he flips it for 10 ETH. I get 10% of that. And if that other person flips it for 20 ETH, then I get 10% of that until forever, basically. Every time it swaps hands, I will be receiving residuals. So it's really in my best interest to sell as many NFTs as well as have other people resell my NFTs and create a lucrative secondary market, because it's not only helpful for the collector, but it's also helpful for me.
And that is a
Yeah.
fully automated process.
Yep.
That you receive those royalties. Wow. Yeah.
Yeah, I can see that how that's attractive.
Yeah. Yeah.
And also the value of your art. I mean, it's always the value of art is determined by how much people want it, basically. But I've read stories, like I don't really know much about NFTs, but I read about those like crypto kitties. I think it's like pictures of cats, and they became super valuable, and people paid a lot of money for them. So that could also happen to your art, basically, if you're lucky.
Yeah.
Is that like, how often does that happen? Is that like 1 in a billion, or is that a common thing on the NFT market?
It's rare. It's very rare. But to be frank, it's rare to even buy one or to sell one. Most people who sell NFTs, they've never sold a single NFT. The fact that I think I've sold 12 by now on separate blockchains as well. That puts me in like the top 5% of NFT artists, simply by virtue of selling more than one. There's a lot of NFTs that have been flooding the market, but just like anything else in the world, any other sales job, you have to do the work, you have to do the legwork, you have to meet collectors, you have to put yourself out there, you have to be part of the community, you have to be marketing yourself. That's the main reason why people continued to purchase from me after the one person who originally wanted it. After he bought my NFTs, I had to do the legwork myself and introduce myself to the community. I would start doing 101s and tutorials. I do frequently asked questions where people would ask me whatever they needed, and I'd help them mint an NFT, or I'd help them understand blockchain, or I'd help them understand their wallets. It just like with anything, the work never stops.
Right. So it's a bit similar to traditional art in that way, right? That there's a kind of big initial investment for the artist, because you also have to pay fees in advance and you don't know if you're selling. So interesting. Yep. Cool. Yeah. And cool that you're so successful, like selling yours. Like, is the art that you make for NFTs, is it different than other art you would make because of the special properties?
Yes. Yes and no. The art that I make is typically extremely different than most people's art anyway, because you know me, I do cross reality artwork where I do like VR stuff, mixed reality stuff, like I do all of these things, and most NFTs are not of that nature. But because my art is software, I do make updates. When I have a collector that purchased one of my, what I like to call them a living NFT. When they purchase a living NFT, they're receiving updates. I will always be progressing on my own skills. And as my skills progress as an artist and as a developer, so will my software and my art. So really, I like to say that when you're buying an NFT from me, you're not just buying one NFT from me, you're buying a lot of them from now into the future.
Okay.
How long are you
Cool.
into the NFT business now?
It's a part of one of the many things that I do. I'm still primarily a developer. I love writing code. And right now I'm just head deep into WebXR because I want to build my experiences outside of walled gardens. And at the same time, regarding my NFTs, I want to be able to have an experience that I could just very easily just provide a small URL and they don't have to download a secondary app or anything else. They could just get to it on a browser, either on their desktop, on their mobile, or on their VR headset, and experience it without a lot of, without too many barriers.
And technically, the NFT, if it's WebXR, what exactly is the NFT? Is it then the URL to that website, or is it a JavaScript code, or is the URL?
It would be the URL, but if as an artist, I could also include the code if I wanted to. Like I could say, okay, you're getting the live website, and I could also send and mint a private GitHub repo as well if I wanted to.
Okay, but then that the live website should always stay online, or is that published to that store, that private store that you were talking about?
For the WebXR experiences, I host it.
You host it yourself. Yeah. Okay, got it. Sounds very interesting. Yeah, cool stuff.
Thank you.
Yes, completely new world.
Yeah.
Awesome.
Yeah, and I was very, very happy to hear that you will come back during the Global XR conference, right? Yeah.
Yes, I would love to.
Yeah, we would love to have you again. Yeah.
Hey, I see there's a question from the audience, actually. Someone's asking, are you making WebXR in just plain JavaScript or some other platform? And I'm assuming, A-Frame or something like that.
I'm using A-Frame and 3.js.
Right. Thanks.
Okay.
Any particular reason why? Now, this is a completely different topic, right? WebXR, but why are you using A-Frame instead of another platform?
Frankly, because I taught myself how to code HTML when I was 10 years old, and HTML and CSS has been the bread and butter of my career ever since I started working. So markup language, whether it's HTML, XML, or A-Frame, it just feels like a bit of like a security blanket because I'm just so used to it. I'm so used to the syntax. I'm so used to how it looks. It just clicks in my brain. So I wanted to at least start off on the path of least resistance for me.
Yeah, I get that. Yeah, it's more accessible when you're coming from that direction than, I don't know, an engine, for example.
Yeah.
Cool. Well, thank you so much. I don't have any more questions. Sjoukje.
No, me neither. No. I am going to digest this for a bit. Yeah.
Well, let me know if you have any other questions eventually. I'm in the Slack channel as well. I love talking about this stuff. And if you'd like to check out my upcoming WebXR NFTs, let me know. I'm really proud of my next collection that's going to be coming out. So,
nice. Yeah. I already checked your website, and that's interesting as well. A lot of interesting links to platforms that you are using. Yeah, looks cool.
Yeah, what's the best way for people to find you?
Best way for people to find me would be my Twitter. Frankly, I'm at Extended Victory. I tweet a lot. I used to never tweet, but Twitter seems to be like one of the primary congregations of the NFT community. So that's where like most of like the NFT artists go, and when you go to my Twitter, you'll see me repost a lot of really good NFT artists, and yeah, I love being able to support and promote the community. And yeah, that's where I'm at. So if you like weird XR stuff and you like seeing curated artwork, and if you like seeing me in cosplay, then my Twitter's the way to go.
Okay.
Well, thank you again so much for your time and for your great talk. We loved having you.
Thank you for having me.
Yes.
I look forward to doing it again.
Well, we
Thank
look
you.
forward to it. Thank you
Yeah.
so much. Thank you. Have a great day.
You too.
Bye-bye.
Bye-bye.
So, Sjoukje, that was two really interesting talks. Completely
Yeah.
different, completely new
Completely different.
topics.
Yeah. Yeah. Yeah.
I
yeah.
enjoyed this very much today.
Yeah, me too. And I have a lot of homework to do after this.
Yes. Crypto kitties.
Yeah.
NFTs. It's really cool.
Yeah.
Oh, that's it for today. I
That's
think.
it for today.
We have a summer
So-
break. So our next event is not next month, but in August.
August, yeah. You're right. Yeah. So then we will return with 2 new speakers. Yeah.
We will.
Yeah.
And again, we are already the website for the Global XR conference is already up. It's globalxrconference.com. And if you are a speaker or if you want to be a speaker, we really, really encourage you to sign up as a speaker on our website for the conference, which is in October, so that you have plenty of time to prepare your talk until then.
Yeah. Yeah. Okay, so let's finish with the Global XR Conference video then. And then we'll see you after our summer break back in August.
See you in
Bye-bye.
August. Bye-bye.